Imagine a world without the internet. No emails, no social media, no video calls. A world where information ceases to flow freely, where global communication grinds to a halt. This is not a scene from a dystopian novel, but a potential reality if a powerful solar storm were to hit Earth. Our sun, the lifeblood of our solar system, is not always the benevolent star we perceive it to be. It is a dynamic and volatile celestial body, capable of unleashing immense energy in the form of solar flares and coronal mass ejections. These events, though visually stunning, pose a significant threat to our technology-dependent world, particularly our global internet infrastructure. The internet, for all its marvels, is surprisingly vulnerable. A complex network of undersea cables, satellites, and ground stations, it relies on delicate electronics susceptible to the sun's powerful outbursts. Understanding this vulnerability is the first step in preparing for a future where a solar storm could plunge us into digital darkness. The sun, a giant ball of hot, glowing gas, is the center of our solar system. It provides the light and heat necessary for life on Earth. However, the sun is not a static entity. It goes through cycles of activity, marked by periods of relative calm and intense activity. These cycles, known as solar cycles, last approximately 11 years. During a solar maximum, the sun is at its most active with frequent solar flares and coronal mass ejections. Solar minimums, on the other hand, are characterized by reduced solar activity. Understanding these cycles is crucial for predicting potential threats to our planet. As we delve deeper into our technological dependence, the stakes rise. A powerful solar storm during a period of peak solar activity could have devastating consequences for our interconnected world. Solar flares are sudden, intense bursts of energy from the sun's surface. These bursts are associated with the release of magnetic energy in the sun's atmosphere. Imagine a rubber band snapping. That's the kind of energy release we're talking about, but on a much grander scale. These flares release radiation across the electromagnetic spectrum, from radio waves to X-rays and gamma rays. While the Earth's atmosphere protects us from the harmful effects of most of this radiation, it can interfere with radio communications and satellite operations. Imagine your GPS going haywire, or your satellite TV experiencing disruptions. These are some of the milder effects of solar flares. In a world increasingly reliant on real-time data and communication, even minor disruptions can have cascading consequences. Coronal mass ejections, or CMEs, are the real heavy hitters when it comes to solar activity. These are massive eruptions of plasma and magnetic field from the sun's corona, the outermost layer of its atmosphere. Picture 1 billion tons of superheated gas hurtling through space at millions of miles per hour. That's a CME. When a CME strikes Earth, it interacts with our planet's magnetic field, causing a geomagnetic storm. These storms can induce electric currents in power grids, potentially leading to widespread blackouts. They can also damage satellites, disrupt GPS systems, and even pose a radiation hazard to astronauts. The internet, reliant on a delicate balance of ground-based and space-based infrastructure, is particularly vulnerable to these geomagnetic storms. CMEs are the solar events most likely to cause significant disruptions, potentially severing the digital arteries that connect our world. In 1859, the world witnessed the most powerful geomagnetic storm ever recorded, the Carrington Event. Named after Richard Carrington, the astronomer who observed the associated solar flare, this event serves as a stark reminder of the sun's potential to disrupt our lives. During the Carrington Event, telegraph systems around the world went haywire. Operators reported sparks flying from their equipment, some even receiving electric shocks. The aurora borealis, typically visible only at high latitudes, was observed as far south as Cuba and Hawaii. While the world of 1859 was less reliant on technology, the Carrington Event provides a glimpse into what a powerful solar storm could do to our modern world. The damage to our interconnected power grids and communication networks could be catastrophic, leading to widespread blackouts and communication outages. The internet, often perceived as an ethereal network, has a surprisingly physical backbone. Undersea cables, spanning thousands of miles across the ocean floor, carry the vast majority of international internet traffic. These cables, while robust, are not immune to the effects of geomagnetic storms. The electric currents induced by these storms can overload and damage the repeaters. essential components that boost the signal along the cable's length. A severe geomagnetic storm could potentially sever multiple undersea cables, disrupting internet traffic between continents. Imagine a world where transatlantic communication is crippled, where financial transactions are halted, and where global collaboration grinds to a halt. This is the potential impact of a major solar storm on our internet infrastructure. Fortunately, we are not defenseless against the sun's outbursts. Space weather forecasting, a relatively new field of study, aims to predict solar flares and CMEs, providing crucial time for preparedness and mitigation. Scientists use a variety of instruments, both on Earth and in space, to monitor the sun's activity. They track sunspots, regions of intense magnetic activity on the sun's surface, which are often the source of solar flares and CMEs. Sophisticated computer models help predict the trajectory and potential impact of these solar events. Just like we rely on weather forecasts to prepare for hurricanes and blizzards, space weather forecasts are becoming increasingly important for protecting our technological infrastructure from the sun's fury. Early warning systems allow us to take preventive measures, minimizing the potential damage and disruption. The duration of internet outages caused by a solar storm would depend on the severity of the storm and the effectiveness of our mitigation efforts. A minor storm might cause temporary disruptions, lasting a few hours or days. A major storm, like the Carrington Event, could have much more severe and long-lasting consequences. In a worst-case scenario, widespread damage to undersea cables and power grids could take weeks, if not months, to repair. Imagine a world where entire regions are cut off from the internet, where communication is limited, and where the global economy is thrown into disarray. The economic and social impacts of such an event are difficult to overestimate. While the likelihood of such a catastrophic event is relatively low, the potential consequences are so severe that it warrants serious attention and preparation. We must invest in research, infrastructure hardening, and emergency preparedness to mitigate the risks posed by solar storms. Protecting our internet infrastructure from solar storms requires a multi-pronged approach, involving both technological solutions and policy measures. One crucial step is to harden our power grids, making them more resilient to the effects of geomagnetically induced currents. This can involve installing surge protectors, adding redundancy to the grid, and developing new technologies to regulate voltage fluctuations. Shielding undersea cables from the effects of solar storms is more challenging. One proposed solution is to install Faraday cages around critical sections of the cable, effectively blocking the induced currents. Another approach is to develop new types of cables that are less susceptible to damage from geomagnetic storms. In addition to these technological solutions, we need to develop comprehensive emergency response plans. This includes stockpiling spare parts for critical infrastructure, establishing alternative communication channels, and educating the public about the potential risks and necessary precautions. The threat posed by solar storms extends far beyond the internet. A major geomagnetic storm could disrupt power grids, communication networks, and navigation systems, potentially leading to widespread blackouts, transportation disruptions, and economic chaos. Preparing for such an event is not just a matter of protecting our technology, but also of ensuring the safety and well-being of our citizens. This requires a coordinated effort from governments, businesses, and individuals alike. We need to invest in research, develop emergency plans, and educate the public about the potential risks. Just as we prepare for earthquakes, hurricanes, and other natural disasters, we must also prepare for the possibility of a major solar storm. By taking proactive steps to mitigate the risks, we can minimize the potential damage and ensure a more resilient future for our technologically dependent world. The sun, the lifeblood of our solar system, is both a source of life and a potential source of disruption. As we become increasingly reliant on technology, our vulnerability to solar storms grows. However, this is not a cause for despair, but rather a call to action. By understanding the risks, investing in research, and taking proactive steps to mitigate the potential damage, we can harness the power of the sun while protecting ourselves from its fury. The future of our interconnected world depends on our ability to embrace both the opportunities and the challenges presented by our dynamic and ever-changing solar system.